Okay, so I wanted to record a hopefully short, hopefully helpful technical demonstration of using Ansible Molecule as well as how you can use that to your advantage. It's basically local Docker container-based testing and how you can use this to your advantage when you combine it with products such as GitHub Copilot. I generally use it with VS Code. I generally find it very affordable on a personal use basis. It's just $10 a month for the Pro plan, and you can usually get higher usage limits. Although businesses, it'll depend on your licensing, whether you have GitHub Team or Enterprise. But generally, I would say if you need additional requests, you can also start with a low plan, and if you exceed that, you can pay for additional requests. It's usually very affordable. I would say about 4 cents per additional request, as I recall. But generally, very low cost, very good pricing model, very efficient for businesses. And I apologize if there's any echoes. I don't have a professional setup. I generally don't have a side hustle as a YouTuber, so I do not have a dedicated microphone that I try to add noise suppression to help cut out some of that. Plus, I don't have professional editing software or experience doing it. So if you do find that I am speaking too slowly or that there's too long gaps, I do plan to upload this to YouTube. So you should be able to set the speed to 1.5 times speed if that makes it more comfortable for you. So, a quick overview is that Ansible Molecule is their native testing framework that's designed to integrate into Ansible. You can use it to test collections, playbooks, and roles. And as I mentioned, it uses Docker container-based testing. So you see, I'm on a Mac and I'm using Docker Desktop Personal. And on the terminal, Docker PS, there's no containers running. They do have other drivers, so you can use Vagrant or let's just say AWS EC2 in order to run full virtual machines. If you do need testing that's based on that, however, in my experience, it hasn't really been particularly great or reliable or even predictable. One time I did try to run Vagrant, just because I had a situation where I needed to test using Linux FIPS, but I wasn't able to really get it running reliably, and it was like pulling teeth to get it to work. So you can safely assume that for Ansible Molecule, Docker, it's designed for Docker first as the primary testing method, and anything else is just secondary. Best effort, I would say. So for today's demo, I wanted to showcase this by running, well, let's just go ahead and run a converge on the scenario first I have here. This is the scenario. I am setting up a clustered Apache Kafka application. This is not something I've actually ever deployed before. However, I did deploy similar applications such as Elasticsearch in a cluster, or Splunk in a clustered with multiple various, multi-node rules. For Splunk, it will be like cluster manager, indexers, search heads, heavy forwarder, as well as like a dummy Linux VM so that I can install the Splunk Universal Forwarder, have it, actually collect and send a little bit of logs. But yeah, generally you don't need too powerful a computer. I would say any modern computer, and you can run a setup like this. For this test setup, there's actually one extra node beyond this. You see 7 nodes over here, 3 Zookeeper nodes, 3 brokers, a root CA. But I also have another container that's running Kafka UI as an additional visualization component. It's not displayed here, but when I make this public, I'll be sure to update it and hopefully probably change this to mermaid diagram. But this is the scenario that I'm going to run. This usually takes about 3 minutes, but this simulates what you would probably actually do in an actual live environment. So if I were to eventually run these Ansible roles against full AWS EC2 Linux instances instead, then you would see a similar process. Although you might swap out certain components. Like right now, I'm using a root CA because this is a local development environment that's running on my local computer instead of actual cloud services. So because I don't have access to, AWS, uh, ACM private certificate authority for certificates for the internal applications, that's why I'm just spinning up like a dummy root CA over here. And I usually do this all the time for local development testing. Maybe I don't have like an RDS Postgres, so I just spin up a simple Linux node, install Postgres on that, and use that as the external database instead. But this is going to take a few minutes to run, so I'm going to, well, I'll probably elaborate a little bit more about what I'm doing regarding Copilots. Let's see here, go to my trusty PowerPoint. So GitHub Copilot has a slightly different pricing model. It's per premium request. You get 300 a month on a pro plan or a team plan, and that resets every first day of the month. And every chat message you send using a premium model has a particular multiplier. If you see a multiplier of 0, then that is effectively free. You can use that as much as you want. There are certain limits. I believe it's primarily API. It's not truly unlimited, but it is effectively unlimited. You can use it as much as you want. It's not going to count against your usage. And usually in VS Code, they'll give you handy percentage of how many premium requests you used. It's not a hard number, so it's harder to track. I believe some people made an extension, like a custom extension, to track that usage better. But that's what you get with weaker and older AI models. So, Grok Code, GPT 4.1 or 5 mini. Now, for the stronger models, newer models such as, Claude, Sonnet 4.5, you have a 1x multiplier. So basically, if I select this model, then every single chat message that I send, whatever I type in here, whenever I hit enter, then that consumes one request. For stronger models such as Opus, it's a 3x multiplier, so one message uses up 3 premium requests. And similar, if you have like a partial modifier, let's just say Haiku, then it'll consume 1/3 of a normal premium request out of your 300 allotted a month. Now, the key point to keep in mind is that if you use agent mode, then basically that will code generally, it'll run continuously. And as long as you don't send another chat message, then that only counts as one request. So it's not efficient if you were to just send a chat message, hey, I want you to make a change on this particular file. That's not efficient. You should either use a free model to do that if you need to, a cheaper model like Haiku if it's just a simple, patch. Or in my case, because we're using Ansible Molecule to test code, then the AI can read the output that's being shown on the screen here. And if there's anything wrong, if you give it instructions to, like some models are less friendly about it. I know that from experience, GPT tends to be a little bit lazy, especially 4.1. That's why some community members have created like a beast mode, chat mode, that basically aggressively tells it, hey, keep trying to execute, fix whatever tasks there is until it's done. But I generally find that the Anthropic AI models, such as Sonnet, Opus, they're a lot more aggressive about continuing to work in an agentic fashion. So that part finished up, and just to demonstrate that I do have like a working application over here. This is the Kafka UI. It's being forwarded. It's got a nice little dashboard over here. You can see that there's one online cluster with 3 brokers, 83 partitions, and you can navigate in here and actually look at some of the data. So I only ran it and set up basic dummy data enough to populate the dashboard so that everything's not empty. You can see in sync replicas, online partition data. But yeah, very basic, very simple. And generally, it's a simple process with other applications as well. If I have an Elasticsearch cluster, that would be Logstash, Elasticsearch, Kibana, multi-node clusters. I might have a lot more nodes in that scenario. I can still run a converge, and generally in about 15 minutes, I will have a working dashboard. I can log into Kibana with a preset username and password for local testing purposes, of course. And similar story with Splunk cluster. I can log in, let it run for about 15, 20 minutes, and then I can log into a search head, cluster manager, or anything with Splunk web UI enabled. And that lets me sanity check my code as well as for development purposes as well. But since that is all good, I will destroy this environment. And the actual technical demonstration is going to be where I have I have a branch over here that's set up to showcase, Copilot debugging, where the Copilot agent actually runs this code, and that's usually something I already set up over here for with a GitHub Copilot custom prompt. It's just a little annoying warning, but that shouldn't really affect the test. And it's a quick and easy slash command. But this is already a basic workflow where if I'm developing a role or collection that I've never really used before, such as Kafka, then I generally want to set up a feedback loop where, hey, I want you to implement either a new feature, develop a new role or code, or fix an existing problem. So I want you to run Ansible Molecule to test it and then analyze the results. So I'm just going to trigger it here. I would say this takes roughly 3 minutes to fully run. And you can see the AI model start kicking off over here. Okay, so that should be going now. One thing I wanted to draw and highlight to you, the thing to keep in mind with using AI like this, or general Ansible use, is that it produces a lot of output, especially when it's in a working state, and you do want it to be in a working state. But that's kind of a problem with using AI because AI has what's known as a context window. You can think of this as like a terminal over here, where you can see certain parts of it, but similar to how a terminal has a buffer, you can only scroll up so far. You can't really, it doesn't save everything you ever did in memory in history. So I can only scroll up to this point. I can't scroll up any further. And the AI context window works similar to this. So if you were to run Ansible regularly and just allow it to vomit out its complete and full output, then that basically causes the AI to run out of that working memory. And it basically starts forgetting what you asked it to do earlier. And it could have been maybe 30 seconds ago. But if there's enough text output where it overruns the buffer, then that's basically it running out of memory. And that's generally why people describe that, hey, the longer I use AI in a single chat session, the worse the experience gets. That's generally, I believe it's described as context degradation. So one of the strategies I took to try to mitigate some of that is that, hey, I want you to run the converge command to run the Ansible test, but I want you to use grep to filter out the output so that you only get maybe play recaps as well as generic failures, failed, fatal, error. And I would say this will take about 3 minutes before we actually hit the failure point. So I switched off to a demo branch and I inserted a something that would, a little configuration issue where it will actually cause the Ansible play to fail. And then it basically showcases why using Ansible Molecule along with AI is useful because you can use local testing, create a very short feedback loop, and then the AI can see the error and diagnose your problems. In my experience, if you ever looked at Linux log files for applications, generally I would describe it as kind of incomprehensible, and I would have to figure out what is a meaningful and directly related error that might be causing issues. Go onto Google, search a particular error code, and see if I can figure out from the search results what might actually be causing my problem. In my experience, AI is much more well trained and much faster, much accurate at the very least, diagnosing what might be potential causes. It might not always be perfect at fixing them, but generally, when I read what the AI says, I can, it's presented to me more in plain English, where it says, hey, this might be like a TLS certificate configuration issue. If I see the AI going off in the wrong direction trying to fix a potential problem, then I can usually interrupt it and steer it back on course. But for now, I'm just going to pause the recording until we hit the error point. Okay, so sorry, got a little bit behind over here, but it did eventually encounter the error, and you can see it spotted it, it's timing out, and it's checking service logs. And it's using Docker exec to access the container. And I was able to eventually find the issue, make some configuration changes, and then it's rerunning the test again. But this does describe the feedback loop that's being highlighted over here. It's generally a very simple loop. Again, run the code or implement new feature, or run the test to check for existing errors. Maybe I notice something and I want the AI to try to debug and fix it. Run it, check the results, analyze it. Is there an error? If yes, then it's done. If not, then try to attempt a fix and then go back to the beginning of the loop. Run, analyze, and fix. Just do that in the loop. And you do see that in the instructions over here where I did kind of ask it to emphasize it just because again, sometimes AI can be lazy depending on the AI model that you choose. I found that Opus is generally a lot more aggressive about continuing, at the very least when they did the initial release, because I did use it for an exotic scenario. Like, one of the things I might find this useful for is if I want to write Ansible rules for unfamiliar software. And the use case I had when Opus was originally released at a promotional discount, they had GitHub had like a 1x multiplier, so it only ate up one premium request, and I was basically I had a lot of requests saved up still. My use case at the time was to create Ansible rules for an Elasticsearch cluster, which is something I've done before, but I haven't really done it using FIPS, trying to enable FIPS within the application. It did take a little bit of custom configuration. I used a Lima VM and used a custom built Rocky Linux image where I just kind of added custom configuration, enable FIPS command. And I was able to use that instead of Docker Desktop because I don't believe Docker Desktop lets you um, customize the underlying Linux kernel in any way. So that was something that I did. It was new ground for me, and Elasticsearch had a number of settings that you had to set in certain ways. Um, but yeah, I was able to use that, and it was for development of a new role. So was basically like starting off point. I didn't really have any code all that well defined yet or fully fleshed out. but I was able to essentially say, hey, we're developing new code, and I want you to develop this code and then use Ansible Molecule to test that the individual rules work, and then run a final uh, aggregated test where you test all the rules together so that, because Elasticsearch is a cluster application, so I want to test the rules individually and then test the entire thing as a collective whole to ensure that everything works properly and the cluster is actually working. And I do, there are some verification playbooks you can make. And depending on how complex it is, you can also use Ansible to make API calls. So that's another way, if you have a clustered application, there's usually going to be an API cluster health endpoint for things like Splunk or Elasticsearch, which you can reach out to and use that to check your applications. And that's usually part of the testing process. It's still struggling a little bit over here to try and fix the code. But as you can see, that single chat request, the slash command I used to run it, the molecule test, this only ate up a single request. And for things like scaffolding out initial Ansible code, you want to pre-test in a local testing environment before you try to move over to more expensive testing, let's say in a sandbox with AWS EC2 instances. This is great for that. You can get most of the, if we're following the 80/20 rule, then you're doing 80% of work locally in a safe testing environment so that when you actually go and plop this onto more expensive resources, EC2, then you have mostly working code. And this is what it does. It's still faster running locally than it would be running on full EC2 instances. But yeah, if you have a good workflow setup, I usually like to run Converge and then idempotence. Idempotence is something that's native to Ansible Molecule, where you just run the plays again and you make sure that nothing changed. If something changed, then idempotence fails. And verify is again just this verify.yaml playbook. It's just something custom that you write to verify that your service actually works. And I chose it's running some native Kafka scripts to basically list them out. And then again, like I said, it reaches out to an API that's being forwarded to check it. But in ideal scenarios, I would say that when I was developing Elasticsearch FIPS configurations, Ansible roles and configurations for that, again, I was able to use Opus for this feedback loop. And I believe one time it almost ran for almost an hour. And I was basically able to use that feedback loop to develop, again, mostly working configurations, Ansible rules for something that's complex like this. And yeah, it wasn't too bad. I think, yeah, I was going from almost scratch, zero, to fully developed and ready for EC2 testing rules for Elasticsearch, FIPS, in about 3 to 4 days. It took me about a week, but I would say 3 days out of that week was just me spent trying to mess around with Vagrant, uh, as well as VMware Fusion to try to run full VMs, again, because it needed FIPS on the Linux kernel. But yeah, that's where most of my time was kind of wasted. But if it weren't for that, I would say for Docker container-based testing, that was just maybe 2 to 3 days of it, which I personally think is very fast. Just because I know for Splunk, when I was developing code for Ansible roles and collections for that, I did we didn't really have AI wasn't really a thing then, and I'm pretty sure that took me at least a month, I would say. So going from a month down to about 2 or 3 days, I think it's fantastic. But yeah, I'll give it another pause since this is going to take a little bit. But since the conversion didn't fail, means the AI managed to get over the inserted failure, which should have been simple. So the rest of this should complete normally. Okay, so this workflow just completed. It did eventually encounter another error, and it did find a configuration error in a separate file. I only intended it to have a single simple one, but this is a good demonstration of how it basically it does in fact keep testing in a loop. As long as you don't flood the context window again, it is my experience that if there's too much context and it overwhelms its window, then it basically forgets instructions, and that's why usually AI misbehaves, and that's when you need to start a new session. Again, that's one of the reasons why I implemented a grepping strategy to basically filter out some of the unnecessary output that Ansible creates, just so that I can focus only on the failure points. But as you can see, when it fails, it does kind of say, hey, this is strange since it's supposed to be working, tries to grep certain properties, files, commands. And I was able to basically determine that it was another configuration file that was being set over here instead of just being in the group vars where something was misconfigured. But it did eventually fix the problem and run a successful test. And this is just basically the fixes that it provided. So basically, to break it, I just changed the port number so that, simple little break, one liner. And I was able to run the converge item potence and then run the verify playbook. So if you were to go over here, you do see that I should have 8 containers running, including the Kafka UI. Visually, you can see that over here in Docker Desktop. And if we go to a web browser and go back to the forwarded post port on localhost, then you do see that, yes, you have 3 brokers, 1 online cluster, partitions online with in-sync replicas, topics, and consumers. So I was able to fix the problem, and then you now have a branch on your code with the fix. But yes, like I said, under more ideal circumstances, again, if it's a fresh collection, maybe I'm making multiple Ansible roles for a clustered application, such as Elasticsearch. Again, once you have the basic framework, the feedback loop established, for iterative testing, you can also use that for initial code scaffolding and development. If you have a well-defined implementation plan, I usually do as a markdown file. And I believe, unfortunately, I only kept the ones to actually break it. But usually I generate an implementation plan. I describe what I want to the AI, have it come up with a fairly large markdown file of what exactly I want to do, and then that's what I feed to AI. But like I said, in more ideal circumstances, I've seen Opus run continuously for nearly an hour in this feedback loop of, again, developing and testing. And it was able to get me, I would say, again, following the 80-20 rule, about 80% of the way there. And for me, uh, my role is to verify the fixes, run the test manually, poke around the application, make sure everything works. But with what AI is capable of these days, you should be able to automate most of that itself. I think if you were to really go the extra mile, you might be able to say, let's just say, I want to, after you run the converge, and it should be, and verify, and it should be in a working state, you could go the extra mile and say, hey, I want you to use a Playwright NCP server, spin up a headless browser instance, navigate to where the port should forward the application, try to log in, click around, navigate, uh, assess, make sure you see what you expect to see, maybe like non-zero partitions, non-zero broker accounts, non-zero active controllers, and whatnot. But yeah, one thing I wanted to cover is that the reason why I have feedback loops like this is because I generally work with infrastructure as code. So I'll use tools, abstracted tools like Ansible, Terraform, and Packer. Now, these are written in Golang and Python respectively. AI is usually trained more on the lower level programming languages. So it's more used to working with Python than it is with Ansible. And similarly, it's probably more used to working with Golang rather than, the abstracted tools that it's written in, such as Terraform and Packer. So the training data isn't quite as good. I believe one example is that in a client project, they wanted to set up a hybrid environment, so AWS and then Azure, and then we're supposed to connect the two sites with a site-to-site VPN. I did have a colleague who had the unfortunate habit of trying to ClickOps the entire thing instead of using Ansible, Terraform, which would have been a better thing. I believe they spent about 3 weeks on it and couldn't get past it. Uh, I proposed to AI what it is I wanted to do. They found an article describing a potential setup on how to actually configure it. And I used the article as a source and say, hey, could you provide me some scaffolded code on what this would look like if I were to use Terraform to create resources, site-to-site VPN resources in both ends? And it was able to do that, but it did have an unfortunate tendency to hallucinate. But that was actually, I would say, a year or more ago where it didn't have quite as strong web searching capabilities. Now it's a lot better, more recent training data. And if it finds things that are inaccurate, it can search the web for more accurate information. But you generally do have to prompt it for that. But the thing to know is that for these abstracted tools, it doesn't have training data, not as much as Python or Golang, actual programming languages. So that's why I would say the probability of you getting working code on the first shot, what I describe as a one shot, is fairly low. But that's why this iterative feedback loop is useful because every time you run it, it can basically say, hey, the AI is notified that your code isn't working and try something else. Uh, I don't know it would proactively search the web, although I do know that GitHub Copilot does have a fetch tool and it does occasionally use it. So depending on, you might say as part of your troubleshooting, do X, Y, and Z. So for Kafka troubleshooting, I just inserted some instructions to say, hey, here's some shell scripts you should run. Here's where some log files that you should check are. Here's some configuration files you can check. And during the actual troubleshooting, you did see it actually do that as part of the skills. So if you were to craft the prompt carefully and say, hey, if something fails, maybe try search the web for more information. Um, but again, that's something you should use carefully, just again, not to flood the context. But with every single iteration you run, you get closer to working code. So that's why this feedback loop is important. And again, to highlight, premium request when before I started chat, I believe it was at about 25%, so it went up 1%. And this testing loop ran for, I would say, roughly 10, 15 minutes. But that only used up one request. So if you're careful about it, then you can basically get the most out of your 300 requests every month. Uh, if you do have a lot of changes that you want to make, again, if you're scaffolding initial code, I used Opus to scaffold this because, again, I'm not familiar with working with Kafka. I don't understand the various components that might be involved, so that's why I created a detailed implementation plan, again, with AI assistance describing what I needed, and then I reviewed it. And then after that's all well and good, I fed that to Opus, and it did uh, write out the code and then use Molecule to test and continuously develop the code. So that was 3 requests, and it was within this month, so maybe like 2%, 3% of this bar. But yeah, that's the best way to get the most out of your GitHub Copilot subscription. I personally think the value is a little bit too good uh, in light of this. So this might be something where you might as well try to use it as long as you have it available before GitHub finally decides that this pricing model might not be as efficient. Because I know if I were to do this, I have a Claude Pro plan, and I know if I were to try to test this, because their pricing model is based on tokens, usually output tokens, input tokens. If I were to run through this one time, I would say maybe 50% of my usage would be gone. And if I were to do it a couple times, then I would basically use up all my allotted usage, and then I'll be locked out, be unable to do anything for the next 5 hours until that resets. But I think that's more of a, for Anthropic, that's more of a like a hobbyist plan anyway. Uh, but yeah, Claude Pro, $20 a month, and that's what I get, maybe 2, 3 requests like this. But for GitHub Copilot, that's just 1% for the entire month. So yeah, that's how to get the most value out of your dollar for this.